Oops. Right, so equivalent fractions, that's our goal. Equivalent. So simplifying, if they say 70 to 10, we simplify it to 7 to 1. We prefer improper fractions. We do not, I repeat, do not want a mixed number. We do not want a mixed number. Keep it as an improper fraction. If it's a simplified fraction like 1/2, that's fine. That's a fraction, it works, it's beautiful. But if you have 4/3, keep it 4/3 instead of saying 1 1/3, which is kind of counterintuitive to what you've been told all throughout elementary school, right? All throughout elementary school, they've said, oh my gosh, what's wrong with that fraction? You can't have 4/3. Well, now we can. And in fact, we prefer it. Right? Maybe a little less work? Yeah. All right, so let's talk about constant of proportionality. You can read along with me. It says down below, right? The graph below represents the price of strawberries at one store. What is the constant of proportionality? So here's my graph, right? So many of you, I know, this is how your parents go grocery store shopping. They make a graph of the produce price, right? I mean, this is commonplace math. No, it's not. It's just an example, right? So the explanation, step 1, the graph of a proportional relationship. You know that something is proportional if it makes a straight line. Does that make sense? Because if we're talking fractions, 20/2, right? That's our first fraction, our first proportion, 20/2. What's my second proportion? 40/4. Are those proportional? Is 20/2 equivalent to 40/4? Yes. Yeah, they're the same, right? So, and you know, if I went 80/8, is that proportional to 20/2? And 40/4? And right? So it's going to make a line because it increases the same amount every time. For every 2 pounds of strawberries I buy, how much more money does it cost? $20. 20 cents. Those are some expensive strawberries if it's $20, right? Really, 20 cents. We need to go there. Yes? That's ridiculous. All right, so it says the proportional graph is a straight line. It passes through the origin. A proportional quantity can be determined by this equation, right? And we'll talk about this equation in a minute. Step 2. So is this a straight line? Step 1, yes. Does it go through the origin? What's the origin? 0, 0. I'm going to highlight the word origin. I'm going to put a note over on this side. Must go through the origin. And you told me that the origin is 0, 0. So it has to go through that corner piece of the graph, right? So is this graph a straight line? Does it go through the origin? Okay. So just by looking at this graph, I can determine, is it a proportional relationship? Step 2, we can tell that the graph is directly proportional by looking at the graph. The graph is a straight line, it passes through the origin, so the relationship is directly proportional. It is proportional. You could also do this from a chart. So what if they didn't give you a graph? What if they gave you a chart? Can you determine if it is proportional? Yes. Here's how you do it. You have the change in y over the change in x. I guess I can write that over here. Give myself a little bit more room. Change in y over the change in x. So we're going to find all of the change in y's and all of the change in x's. What color? Green, maybe? And I'm going to just put it like kind of, it's hard because I know it's small, but what's the change from 40 to 60? 20 over. What's the change from 4 to 6? 2. So what's that change in y over change in x? 20 over 2, correct? All right, let's find the next one. What's the change from 60 to 80? 20. And what's the change from 6 to 8? 2. So what's the change in y over change in x? 20 over 2. Most of you are going to be like, Mrs. Long, let's stop here. Are those the same? So yes, that's proportional. Here's what I'm going to tell you. On a test, the state assessment, you need to check every single one in the table. Because what they will do to you is they will make these two proportional, and then they'll change this last one. So they'll get you to be lazy and only check 2 of them, and you'll say, yes, it's proportional, where you need to check all of them, because what they'll do is that last one, they'll make it 20 over 3. And is that proportional? No, they all have to be proportional. If they're all proportional, it makes a straight line. Okay? So let's check the last one. I get it. But these precious seconds of your life are going to be spent in math class anyway. 80 to 10, 20. And 8 to 10. So my rate of change, my constant of proportionality, is 20 over 2. However, ladies and gentlemen, my constant of proportionality, my most simplified, right? My proportional relationship is 20 cents for every 2 pounds. That's my proportional relationship. But my constant of proportionality is not 20 over 2. It is
10 over 1.
10 over 1 because I have to have the most simplified answer. So my constant of proportionality, which is an awesome word to spell, is 10 over 1. And 10 over 1 is improper, correct? But if I simplified it, would it change to a mixed number? No, it would just change to a what? 10. An integer, 10, right? So that's okay, as long as if I simplify, it does not make a mixed number. So my constant of proportionality is 10. My constant of proportionality is 10. So my equation, remember when it talked up here about your equation, y equals kx? Your equation is just y equals 10x. You take your x value and multiply it by 10 to get your y value. Is that true? 4 times 10 is 40. 6 times 10 is 60. 8 times 10 is 80. 10 times 10 is 100. Try these 3 problems with your table. See if you can figure out the constant of proportionality. How much do you go up is your change in y. How much do you go over is your change in x, right? Graphing. Y is vertical, x is horizontal. I know there is one. I know there is a constant of proportionality because it's a straight line that goes through the origin. Don't bother making a table. I mean, if you want to, go for it. But could you just count? Remember, constant of proportionality, once you get those fractions, you have to simplify it. Either into a regular old fraction, an improper fraction, or a whole number. No mixed numbers. So if I'm looking at number 1, what is the constant of proportionality? How much do I go up? 60 over, and how much do I go over? 30. So could I write down y equals 60 over 30x? I mean, I could. But is that my constant of proportionality, or is that just a proportion? That's just a proportion. It's not simplified. So what if these both have a 0, so I'll cancel those out. So 6 over 3, is that it? What is it? 2 over 1, yeah? Which can be made into 2. All right, next one. My change in y is, I'm going to go here, 80. And my change in x is what? 2. Did anybody else find a different one? Did everybody use 80 over 2 as your first fraction? What did you use? 40 over 1. Is it okay that I did 80 over 2? Because they're what? They're equivalent fractions. They mean the same thing. Are either of those the final answer? No. 80 over 2 simplifies, and so does 40 over 1. What do they simplify to? So my equation is y equals 40x. Meaning if I take my x value and multiply it by 40, I will get my y value. Last one. Is there a proportional relationship? What are the two things you need to know? Straight line goes through the origin. Perfect. I go up 10 and I go over 1, yes? Is that my answer? Because I can simplify it to, so my equation is perfection.